Okay, hi again guys. So this video is especially to explain on example 4.3 in your textbook.
So, it's complicated example, okay, in this chapter, which is example 4.3. Okay, initially given to you this table, okay, with initial solid concentration is 250 milligram per liter. Okay, so the question want you to find the overall removal efficiency where with 3 meter deep, okay, like the column lah, 3 meter deep. Okay, this column. Okay, imagine this is 3 meter deep. Okay, at a retention time of 1 hour and 45 minutes. Okay, so before you can plot, you need to plot this graph in order for you to solve this. So in order for you to plot this, you need to convert the data into in the table into other data. Okay. Okay, I've already did half part of it, halfway lah, then you will solve the rest. Okay, so this was given in the example, okay, with retention time 105, C naught is 250, and the depth is 3 meter. Okay, so you need to convert this data to this data in order for you to plot this graph. So this graph is actually depth versus time. Okay, so if you look here, you can see, okay, depth given 0.5, okay, up to 3 meter because the depth is 3 meter. And then the time of sampling is 30, and this one is from the question. So this one you need to find. How are you going to determine this? This is actually the fraction, okay? So the formula is xt is equal to 1 minus ct over c naught times 100. So for instance, just now we have, okay, you look here at that 0.5 times 60 here. Okay, it's 83, right? So 1 minus 83 over 250 is actually your initial concentration just now. Okay, and then you will get 0.67 times 100, so you get 67. So you do that for the rest of this. Okay, that's a lot, huh? So for every time of sampling. So after you finish doing this, you can plot it here. Okay, so initially there's no line here. I want to show you that you will only initially you will plot this point here. So this is actually taken from, if you look here, at 30 minute sampling time. Okay, see 30 minutes, then you plot it here. Okay, so at 30 you know just now. So for instance, 30 at 3 meter depth at 30 minutes sampling time. So at 10 the depth is 3. So here 10, 3, and then the rest is, say here 12 is 2.5. So 12, 2.5. So it's actually you just plotting the the depth over time. So this value is like agak-agak. Okay, you assume. Okay, so you will do the rest for this. How many column are they? So 1, 2, 3, 4, 5, 6. So that's why in the book you will see. Sorry. So that's why in the book you will see there's this point, right? So 30, 60, 90, 100, 150, 180. So it's about the same one. Okay. So how do you get all these lines? Okay, that's the most trickiest part. Okay. Continue after this. Okay, so let's try to plot this iso removal lines. Okay, the one that you're confused now. So just now we plot the point here, right? So now we wanted to plot this. Okay. So you just neglect the green colors line, then that was a work of art of my son. Okay. So okay, so you look here in the table. If you understand the table, it's actually, this is actually percentage of removal. Okay, so here you can read here, okay, for instance here, okay, at 3 meter depth, okay, so it is 10% removal. Okay, so, and when you look here, okay, so the first point here is actually at 30. So you can see 10 here just now when we plot the data. So we actually it depends on you to, you know, to do the ISO removal line at any percentage. So just pick an easy number like 10%, 20%, 50%, like the book has done for you. Okay, so 10% removal. So this is ISO removal. So you can see it's actually falling. Okay, it was supposed, this is like you agak-agak assume. Okay, so this is 10%. Okay, from the table just now. So at 30 minutes, okay, 10%. So you can start here. 10% must be at here. Okay, so you plot, you just draw a straight line here. Okay, for the next line, okay, that 20%. Okay, if you look here, okay, the next value, okay, it is 25 at 60, right? Okay, 60 retention time, but 3 meter depth. Where I can get that? So here, okay, at 3 meter depth is at 60 minutes, it's 25%. Okay, so the point here at 60 would be 25. So your ISO removal line for 20% should be lesser than 25, right? 20. Okay, but must be larger than 10 because this is actually your assumption. Okay, right? So that's why we get here. And then you prolong the line. Okay, if you look here, this is 15, this is 33, right? So you are actually wanted to draw a 20% ISO removal. So it must be in between 15 and 33. Oh, okay. And here, it has to be between 19 and 40. So slightly above 19, isn't it? Right. So at 1 meter depth is 28. So the ISO removal line for 20% is less than 28. Okay. So you draw a straight line. It's just some agak-agak. Okay. Okay. So let's try another value. Okay. Let's say for 30% ISO removal. Okay. So when you read from the table here, at 3 meter, okay, let's say at 3 meter, 60 minutes, right? 3 meter, 60 minutes, it will be 3 meter, 60 minutes, it will be 25. 3 meter, 90 minutes, it will be 38. You see here? Okay, it's 25 and 38. Right. So we wanted to draw the 30% removal. So you have at this point the line must be in between 25 and 38, right? So when up to this point, it must be between 30 is between 28 and 42. So here there is the point 33. It must be lower than 30, right? 33. So 30 is lower than 33. Okay, proceed. Above here is between 19 and 40. Okay, so here 28 slightly, 30 is slightly above 28. So, okay, you resume. Okay, so now we wanted to determine, okay, the step 4, we wanted to determine at T0, okay, See, not 105. This is detention time just now at 105. How many percentage is being removed? Okay, so you see, you have a look here. Where is 105? Is somewhere between 90 and 120. So just now you have, okay, if you don't want to plot the ISO removal line just now, is okay, but you can also plot directly at 105, 40 like this. Okay, so you know, with some extrapolation, it will be around above 40 is around 43 lah, agak-agak. Okay, so